Hello friend, today we are going to start the second nonlinear equation method, that is the Newton-Raphson method. First, see the algorithm of this method. Let x0, y0 be an initial approximation to the root of equation f of xy is equal to 0 and g of xy also equal to 0, that is equation 1. If x0 plus h and y0 plus k is the root of the system, then we must have f of x0 plus h, y0 plus k is equal to 0 and g of x0 plus h and y0 plus k is equal to 0, that is equation number 2. Assuming that f and g are sufficiently differentiable, we expand both functions in equation 2 by Taylor series. To obtain, the Taylor series, and we obtain f0 plus h into del f upon del x0 plus k into del f upon del y0 up to the n term, that is equal to 0. And second, z0 plus h del g upon del x0 plus k del g upon del y0 dash up to the n term, that is equal to 0, that is equation number 3. Where del f upon del x0 is equal to del f upon del x at x is equal to x0 and f0 is equal to f of x0, y0, etc. Neglecting the second and higher order derivative, terms, we obtain the following system of linear equation. That is h del f upon del x0 plus k del f upon del y0 is equal to minus f0, and h del g upon del x0 plus k into del g upon del y0 is equal to minus g. That is equation number 4. Equation 4 possesses a unique solution if d is equal to mod of del f upon del x0, del f upon del y0, del g upon del x0, del g upon del y0 that is different from 0. That is equation number 5. By Cramer rule, the solution of equation 4 is h is equal to 1 upon d into minus f0 del f upon del y0 minus g0 del g upon del y0, and k is equal to 1 upon d del f upon del x0 minus f0 del g upon del x0 minus g0. That is equation number 6. The new approximation are x1 equal to x0 plus h and y1 equal to y0 plus k. That is equation number 7. And the process is to be repeated till we obtain the root to the desired accuracy. When this process is repeated to the accurate root, then we see the problem of Newton's Rasphons method. Same problem of iteration method is given, example, and solved by Newton-Raphson method. Solve the system of equation y square minus 5y plus 4 is equal to 0 and 3yx square minus 10x plus 7 is equal to 0 using Newton-Raphson method. First write the solution, then write given f of x is equal to 3yx square minus 10x plus 7 is equal to 0 and g of x is equal to y square minus 5y plus 4 is equal to 0. Then find del f upon del x, that is 6xy minus 10, and del f upon del y, 3x square. Then find del g upon del x, that is 0, and del g upon del y, that is 2y minus 5. Taking x0 is equal to y0 is equal to 0.5, we obtain del f upon del x0 is equal to minus 8.5 and del f upon del y0 0.75. Del g upon del x0 is equal to 0 and del g upon del y is equal to minus 4. F of x0 y0 is equal to f0 is equal to 2.375 and g0 is equal to g of x0 y0 and that is equal to 1.75. Putting the value of x0 and y0 in above equation f of x and g of x, then we get this value. Hence, then find d. D is equal to, we know, mod of del f upon del x0, del f upon del y0, and del g upon del x0, and del g upon del y0. That is equal to minus 8.5, 0.75, 0, minus 4. After calculating, the value is 8.5 multiplied by 4 minus 0, that is equal to 34. Then h is equal to 1 upon d into mod of minus f0 del f upon del y0 minus g0 del g upon del y0, and that is equal to 1 upon value of d is 34 minus f0 is equal to minus 2.375, 0.75 minus 1.75 minus 4. After calculating, h is equal to 1 upon 34 into minus 2.375 into minus 4 minus of 0.75 into minus of 1.75. After calculating, this value is equal to 0.3180. This is the value of h. Then find k. K is equal to 1 upon 34 into, first write the formula, del f upon del x0 minus f0 del f upon del g upon del x0 minus g0. Putting this value 1 upon 34 into minus 8.5 minus 2.375, 0 minus 1.75, and that is equal to 1 upon 34 into bracket minus 8.5 multiply by minus 1.75 minus 0, that is equal to 0.435, and it follows that x1 equal to x0 plus h. We know x0 is equal to 0.4 plus h is equal to 0.3180, that is equal to 0.8180, and y1 is equal to y0 plus k, 0.5 plus 0.4375, that is equal to 0.9375. For second approximation, we have del f upon del x1 is equal to 6 into 0.9375 into 0.8180 minus 10, and that is equal to minus 5.3988, and then find del f upon del y1, that is equal to 3 into 0.8180 whole square is equal to 2.0074, and then del g upon del x1 is equal to 0, and del g upon del y1 is equal to 2 into 0.9375 minus 5, and this value is equal to minus 3.125, and f1 is equal to f of x1 y1, putting the value of x1 and y1, and then value is equal to 0.7019, and g1 is equal to g of x1 y1, and that is equal to 0.1914, and d is equal to, first write the formula, del f upon del x1, del f upon del y1, del g upon del x1, del g upon del y1, putting this value minus 5.3988, 2.0074, 0 minus 3.125. After calculating, this value is equal to 16.8712, and hence h is equal to 1 upon d minus f1 del f upon del y1 minus g1 del g upon del y1, and putting this value 1 upon 16.8712 into mod of minus 0.7019, 2.0074 minus 0.1914 minus 3.125. After calculating, we get h is equal to 0.1528, and k is equal to, write the formula, 1 upon d into del f upon del x1 minus f1 del f upon del y1, del g upon del x1 minus g1, putting the value of all function, that is 1 upon d means 1 upon 16.8712 mod of minus 5.3988 minus 0.7019, 0 minus 0.1914. After calculation, k is equal to 0.0612. This is the value of k. It follows that x2 is equal to x1 plus h, that is equal to 0.8180 plus 0.1528, and that is equal to 0.9708. That is the value of x2. Then find y2. y2 is equal to y1 plus k, and that is equal to 0.9375 plus 0.0612, and that is equal to 0.9987. That is the value of y2. Now again same procedure is used and find f2 is equal to f of x2 y2, and this value is equal to 0.20061, and g2 is equal to g of x2 y2, and that is equal to 0.0093. Then find del f upon del x2, that is equal to 6 into 0.9987 into 0.9708 minus 10, and this value is equal to minus 4.18277. And find del f upon del y2, 3 into 0.9708 whole square, and that is equal to 2.8274. Then find del g upon del x2, that is equal to 0. Then find del g upon del y2, that is equal to 2 into 0.9987 minus 5, that is equal to minus 3.0026. Again find the d. Same formula is used. D is equal to del f upon del x2, del f upon del y2, del g upon del x2, del g upon del y2. Putting this value minus 4.18277, 2.8274, 0 minus 3.0026. After calculating, the value of D is 12.5592. Then find H. H is equal to 1 upon D into minus F2 del F upon del Y2 minus G2 del G upon del Y2. Putting this value, and answer is 0.05005. Then find again K, and K is equal to 1 upon D into del F upon del X2 minus F2 and del G upon del X2 minus G2. After putting, this value is equal to 0.00309. It follows that x3 is equal to x2 plus h, that is equal to 0.9708 plus 0.05005, and that is equal to 1.02085. And y3 is equal to y2 plus k, that is 0.9987 plus 0.00309 is equal to 1.0018. Substituting this value in given equation, we find this correct to the 2 decimal place. Substituting these values in given equation, we find that these are correct to two decimal places. This is the example of Newton-Raphson method. Thank you.